This is a key to test one. So problem one, it says solve the following linear equation. Again, you have to make sure you show all the work to receive full credit. So the first thing you need to do here is to use a distributive property. So we're going to multiply every term that's in this parentheses by 2, because that's what this says. So 3x plus 2 times what's inside this parentheses. So you have to make sure you multiply first. So distributive property. So I get 3x plus, and then 2 times x is 2x, and then 2 times a negative 1 is a negative 2, and then I'm going to write everything else down. So plus x equal 8x minus 3. All right, so then the next step is to notice that on the left side, I can combine like terms. So I have 3x, 2x, and x that are like terms. So 3x plus 2x is 5x, and then 5x plus this 1x is 6x. So I get 6x minus 2 equals 8x minus 3. All right, and so at this point, to continue solving this linear equation, I can bring the variables to the left or the right. It does not matter. I'm going to go ahead and bring the variables to the left, to the right-hand side. So I'm going to go ahead and subtract 6x from both sides. And remember, what you do to one side, you do to the other. And I'm aligning the like terms to help me with combining like terms. So now when I combine like terms, 6x minus 6x is 0, so I have 0, subtract 2, which is a negative 2, equals, and then 8x minus 6x is 2x. I get 2x minus 3, and then the next step is to add 3 to both sides, and so negative 2 plus 3 is 1, so I get 1 equals, this is 0, negative 3 plus 3 is 0, and you get 2x. At that point, to get x by itself, the coefficient of x is 2, so right now I'm multiplying x by 2, and we'll go ahead and rewrite this way. So remember, 1 equals 2x means the same thing as 2x equal 1, so I can transpose the sides. So if I divide both sides by 2, the solution is x equal 1/2. All right, and go ahead and leave it as a fraction. So leave it as 1/2 and reduced, and this is reduced. Okay, so that's number one. Number two, so in number two, it's similar to number one, except this time you have two sets of parentheses. Mistakes students make, though, some students make, is they see that 2 plus 3 and they want to add that together right away. So they want to say 5. That's mathematically incorrect. So remember the order of operations. You have to multiply before you add. So you have to do the distributive property first. So we're going to use the distributive property here, and we're also going to use it here. So I get 2, and then when I distributed 3 times 4x is 12x. 3 times positive 1 is 3, and then subtract 7 equal, and then using the distributive property here, so every term that's inside this parentheses, I have to multiply by 2. So I get 2 times 2x is 4x, 2 times a negative 2 is a negative 2, and then plus x. And then just like we did in number one, so at this point, the next step is to combine like terms on both sides. So there's only one term with x here, so I'm just going to rewrite the x term, so that's 12x. But I can combine 2, positive 3 is 5, right? And then 5 and a negative 7 is a negative 2. So this left side, when I combine like terms, becomes the expression 12x minus 2. That's going to equal this side, and the only like terms are 4x and x. So 4x and x is 5x. I get 5x minus 2. All right, so just as we did in this problem, we got to this point here. I'm going to bring the variables to one side, constants to the other. This time I'm going to bring the variables to the left-hand side. So I'm going to subtract 5x from both sides. Notice what you do to one side, you do to the other. So when you subtract from one side, you have to subtract from the other. If you add to one side, you have to add to the other, all right, to keep that equation balanced. 12x minus 5x is going to be 7x. I get 7x minus 2 equals, this is 0. 0 subtract 2 is a negative 2. Adding 2 to both sides this time, this is 0 and this is 0, right? So I get 7x is equal to 0. At this point, to get x by itself, we're going to divide both sides by 7 and then reduce. 7 divided by 7 is 1. 1 times x is x. And 0 divided by 7 is 0. So your solution is 0. So there's your work. There's a solution. Okay? All right, so that's number 2 rather. Okay, now number 3. So we have this linear equation, except this time this linear equation contains fractions. Now, it's very hard to see the fractions here, so I'm going to go ahead and rewrite this equation over. We have 5, 6x minus a fourth is equal to 2/3. Okay, so the best way to do this is to clear the fractions. So we're going to multiply both sides by the least common denominator. So the least common denominator of 6, 4, and 3 is 12. So I'm going to go ahead and multiply both sides by 12. Now notice on this left-hand side I have two terms here. So both of those terms need to be multiplied by 12. So I'm going to put that in parentheses or brackets. So I get 12 times the left side, which is 5, 6x minus a fourth. And then that's going to equal 12 times the right-hand side. All right. And then at this point, notice I introduced parentheses or brackets. So now I'm going to have to multiply every term inside this in this case, brackets by 12. So that's a distributive property. So I get 12 times 5, 6x minus 12 times a fourth. So every fraction here, every term has to be multiplied by 12, and that's what you see here. And that's going to equal 12 times 2/3. All right, at this point, so the whole purpose of multiplying both sides by 12 is to get these denominators to be factors of 1s. And so when I reduce now, I will get factors of 1s in those denominators because this LCD is always going to be divisible by these denominators. So 12 divided by 6, I can reduce. 12 divided by 4, I can reduce. 12 divided by 3, I can reduce. So 6 and a 6 is 1, 6 and a 12 is 2. 4 and a 4 is 1, 4 and a 12 is 3. 3 and a 3 is 1, 3 and a 12 is 4. So 2 times 5x is 10x minus 3 times 1 is 3 equal, and then 4 times 2 is 8. So now I have a nice linear equation without any fractions anymore. So at this point, let's go ahead and add 3 to both sides. And so I get 10x, this is 0, equals 8 plus 3 is 11. And then divide both sides by 10 and then reduce, I get x to be 11/10. And so that's the answer to number 3. Okay, number 4, same thing. I have fractions involved. So let me go ahead and rewrite this over. I have x minus 2 divided by 5, subtract, and then the numerator here is x plus 4 divided by 2 equals 3. Now, notice that this 3, if you want to, you can write this as 3 divided by 1. And so if you look at all those denominators, 5, 2, and 1, the LCD is going to be 10. So just as we did in the previous problem, we're going to multiply both sides by 10 to clear those fractions and get those denominators to be factors of 1. Notice, so in this, on the left side, you have two fractions. So we're gonna put that in brackets or parentheses, and we're going to multiply by 10. So I have 10 times x minus 2 divided by 5 minus x plus 4 divided by 2 equals, and then 10 times 3. Distributing, I get 10 times this fraction. I'm going to put the numerator, though, in parentheses just to be careful. So this numerator needs to be put in parentheses, divided by 5, and there's a reason you need this to be in parentheses, minus 10 times, same thing here, x plus 4 in parentheses, divided by 2. So 10 times this fraction, which is what you see here, and then 10 times this fraction is what you see here, and that's going to equal 10 times 3, which is 30. Now, remember at this point, this is where when you reduce, those factors here need to be 1s. 5 into 5 is 1, 5 into 10 is 2. 2 into 2 is 1, 2 into 10 is 5. Now, the reason why we put parentheses here is because now each of those terms that's in the numerator needs to be multiplied by 2. So in reality, you have this. You have 2 times x minus 10. And so remember, every term here has to be multiplied by this 2, every term in that numerator. Same thing here. So subtract 5 times x plus 4 equal 30. Okay, now at this point we're going to distribute. So as we're indicating, every term here needs to be multiplied by 2. Every term in this numerator needs to be multiplied by 5, and that's what you see here. In this case, negative 5. So 2 times x is 2x. 2 times negative 2 is a negative 4, so 2x minus 4. A negative 5 times x is a negative 5x. A negative 5 times 4 is a negative 20 equals 30. Combining like terms, 2x and negative 5x is a negative 3x. A negative 4 and a negative 20 is a negative 24, equal 30. Adding, so at this point, notice I clear the fractions, right? There aren't any fractions now. It's an easy process. Adding 24 to both sides to get that term, the variable term by itself, I get, let me go ahead and write it here. I get negative 3x, this is 0, is going to equal 30 plus 24 is going to be 54. And dividing both sides by negative 3, at this point, negative 3 divided by negative 3 is 1. 1 times x is x. So I get x to be 54 divided by negative 3 is a negative 18. So you must write it as negative 18. And so that's the solution for number 4. All right. Number 5, so let's take a look at number 5. So number 5, we have this application problem. And it's very hard to read, but just listen carefully. So it says find 2 consecutive odd integers if twice the larger increased by the smaller equals 79. And on your paper it indicates the following. The expressions for the odd integers, you're going to set up the correct equation and solve, and then answer the question in complete sentence. All right, so that part A is basically asking you to do this. So you're dealing with two consecutive odd integers. So you got to remember how to write those unknowns. So the first consecutive odd integer is going to be x. Remember that? The second consecutive odd integer will be x plus 2. So that is part A. So that's what you have to write for part A. So the first, and you could have said the first integer is x, second integer is x plus 2. As long as you remember they are going to be odd. Okay, now you're going to set up the equation based on what you read. So it says twice the larger. So that x plus 2 is going to be the larger. So here's your equation. Your equation, you're going to say twice the larger, so 2 times x plus 2, increased by the smaller. So we're going to call this the larger, and this will be the smaller. Okay? So twice the larger increased by the smaller, so plus x, is going to equal 79. And there's the equation. So 2 times x plus 2 plus x equals 79. All right, and then we're going to solve this equation and answer the question. So we're going to distribute. So I get 2 times x is 2x, 2 times 2 is 4, plus x equals 79. Combine like terms, 2x plus x is 3x, 3x plus 4 equals 79, and then getting the variable term by itself, we're going to subtract 4 from both sides. Combine like terms, I get, at this point, I get 3x equal 79 minus 4 will be 75, right? Okay, so now at this point, we're going to divide both sides by 3, and then I get x to be 25. All right, now I just look right here. This is where you got to recognize if what you have makes sense. So first of all, it's an integer, so this needs to be an integer. 25 is an integer, and it is odd. So far I'm on the correct track. All right, so this does make sense at this point because it's an odd integer. All right, now remember you got to answer the question. So they want you to find 2 consecutive odd integers. So you're told x is 25. So right here, what that means is that my first integer is 25, and my second integer is 25 plus 2, which is 27. And so your sentence, you're going to say this. You're going to say the 2 consecutive odd integers are 25 and 27. All right, so that was number 5. Okay, number 6. So number 6, you have this compound inequality, and you want to graph the solution set, and you also want to write the solution set in interval notation. So this is a pretty easy one to deal with. So let's go ahead and rewrite this over. And so to solve this, you're basically going to get the variable term in the middle. So I'm going to add 1 to all parts. Okay, I'm going to add 1 to all parts. So negative 4 plus 1 is a negative 3. It's less than 3x. It's less than 5 plus 1 is 6. And so to find the solutions to this inequality, the next step is to get x by itself. So we're now multiplying this x by 3. The opposite is divide by 3, but I need to divide all parts by 3. So negative 3 divided by 3 is a negative 1. It's less than x. It's less than or equal to 2. So the solution to this inequality here, this compound inequality, is any real number between negative 1 and 2, including 2, because of that equal sign. All right, so in terms of the graph, I would just put negative 1, 2, and there are a couple ways, there are 2 ways you could have had your graph here. So one way is to use open circles and closed circles. So since there's no equal sign on negative 1, we're going to put an open circle. Since there is an equal sign on 2, that means 2 is going to be a solution, so it'll be a closed circle, and you're going to shade everything between them. Okay? The other way, instead of using open circles and closed circles, you could use parentheses and brackets instead. So here's negative 1, here's 2. So make sure it looks like a parentheses though. So over negative 1, and then here's negative 2, the little tick mark for tick mark for 2. This time I have to use a bracket though. So make sure it looks like a bracket. And then shade in everything between. And then your interval notation will be, and basically you just read this part here from your graph. So open circle, parentheses, negative 1, comma, 2 with a bracket. And so there's your solution. Okay? So that's number 6. Number 7, so we have a linear inequality, and that's an easy one. So let me go ahead and rewrite this over. We have negative 4x plus 3 is less than x minus 1. I'm going to go ahead and bring the variables to the left-hand side. So when I do that, that should be minus x here. All right. So I'm going to subtract x from both sides. A negative 4x and a negative 1x is a negative 5x plus 3 is less than x minus x is 0. 0 and a negative 1 is a negative 1. Subtracting 3 from both sides, I get negative 5x is less than negative 1 and negative 3 is a negative 4. And then at this point, we have to get x by itself. And so I'm going to divide both sides by negative 5. But remember, you have to remember the fact that whenever you multiply or divide both sides of an inequality by a negative number, you have to reverse an equality symbol. So since I am dividing both sides by a negative number, I'm going to have to change less than to greater than. So 1 times x is going to be greater than, and then negative divided by negative is a positive. So greater than 4/5. So any real number greater than 4/5 will be a solution to this inequality. All right, and so the graph, so let's do the graph here. So the graph, you can use parentheses. Since there's no equal sign, it will be parentheses or open circle. So let's say this is 4/5. So you'd have open circle going to the right. Or you could have 4/5, parentheses going to the right. Okay, so any one of those is fine. Now the interval notation, you just read it from your graph, you're going to say parentheses 4/5 all the way to infinity. All right, so any real number greater than 4/5 is going to be the solution to this inequality symbol, this linear inequality. Number 8 is also a linear inequality, except this time you have to use a distributive property. So let's go ahead and rewrite this over. You have 2 times x minus 3 plus 4 is greater than or equal to x minus 2. So using a distributive property, I get 2 times x is 2x, 2 times negative 3 is a negative 6, plus 4 is greater than or equal to x minus 2. Combining like terms, negative 6 and 4 is a negative 2, right? So I get 2x minus 2 is greater than or equal to x minus 2. So just like we solved a linear equation, we're going to bring the variables one side, constants to the other. So let's go ahead and subtract x from both sides, and then combine like terms. 2x minus x is x, minus 2 is greater than or equal to, and that's 0, subtract 2, which is negative 2. adding 2 to both sides. When I combine like terms, this is 0 and this is 0. So I get x is greater than or equal to 0. All right, and so your graph, so any real number greater than or equal to 0 is a solution to this linear inequality. So the graph, again, you could use, now remember there's an equal sign here, so 0 is actually a solution. So you would use either closed circles or brackets. So if this is 0, you could put a closed circle here, and any real number that's greater than or equal to that. Or you could put a bracket instead, and then any real number greater than or equal to that. The interval notation, we'll put that here. Interval notation will be bracket 0 to infinity. All right, so that was number 8. Okay, number 9. So number 9, you wanted to graph this following linear equation. Now the directions are important. It said you will need to plot 3 points and indicate the coordinates of the point on the graph. So the first thing I would have done here is write this in slope-intercept form. So let me go ahead and rewrite this over. So we have 4x plus 3y is equal to 15. And so if I get y by itself, remember that slope-intercept form, y by itself, I'm going to subtract 4x from both sides. And so I get 3y equals negative 4x plus 15. Then dividing both sides by 3, and then rewriting this, I get y equals negative 4/3 x, negative 4/3 x, and then 15 divided by 3 is 5. All right, so from here, then we're going to find 3 points on that line. And remember, since the slope is a fraction, it's always easiest to use values of x that are divisible by 3. So for example, 0, 3, 6, negative 3, negative 6, and so on. All right, and so I'm going to use, so those are going to be my 3 values of x I'm going to use because it does indicate 3 points. So if x is 0, I get y equals negative 4/3 times 0 plus 5. Negative 4/3 times 0 is 0, and 0 plus 5 is 5. So one of my points is 0, 5. Then when x is 3, let's go ahead and do that one. I get y equals negative 4/3 times 3 plus 5. Negative 4/3 times 3, that's going to be a negative 4. So negative 4 plus 5, which is 1. I get the point 3, 1. And then finally 6, I have y equals negative 4/3 times 6 plus 5. And then let's see, so 3 into 3 is 1, 3 into 6 is 2, right? So negative 4 times 2 is negative 8. So I get negative 8 plus 5, which is negative 3. Negative 3. Now you had to graph this, so on your graph paper, so we have the point 0, 5. So 0, 5 is here. Now it said indicate the coordinates, so you had to say 0, 5. You had to say that. Then the other one is 3, 1. So 3, 1's here. You had to indicate the coordinates. You had to label that. And then 6, negative 3 is here. 6, negative 3. All right, and then you draw your line, and that is your graph. So that's the graph of that line. So you get something that looks like this. Now notice the line decreases, right? So as you go from left to right, the line decreases. The line falls. So we knew it had to do that because the slope was negative 4/3. All right, so that was number 9. So number 9, you had a graph. All right, and you had to label those 3 points. You had to put 3 points on that line, and you had to label them. You had to show that. Okay, number 10. Number 10's easy. You just need to find the slope of that line that contains those points. So the slope formula is y2 minus y1 divided by x2 minus x1. And the order matters in which you subtract, so be careful. So I'm going to go ahead and label this. So this will be my first point. This will be my second point. So I'll call this x sub 1, y sub 1, x sub 2, y sub 2. So I get y2, which is negative 6, subtract y1, which is negative 2. Divided by x2. Since I started at y2, I have to start with x2, which is negative 7, subtract 4. So the numerator here becomes negative 6 subtract a negative 2 becomes negative 6 plus 2. And then negative 7 subtract 4 becomes negative 7 plus a negative 4. So the numerator is a negative 4, right? Negative 6 plus 2 is a negative 4. And negative 7 plus a negative 4 is going to be a negative 11. But you got to remember, a negative divided by negative is a positive and leave it as a fraction. So there's a slope. So that's number 10. Okay, number 11. So in number 11, the directions tell you to write this linear equation in slope-intercept form. So slope-intercept form is where you get the variable y by itself. So it's pretty easy to do that. So let's go ahead and let's do that here. So I get 4x plus 3y equal negative 12. So if I'm going to get y by itself, I got to subtract 4x from both sides. And when I do that, I get 3y equals negative 4x minus 12. And now dividing both sides by 3 and reducing, I get y equals negative 4/3 x. And then a negative 12 divided by 3 is a negative 4. And then once it's in slope-intercept form, remember slope-intercept form is y equals mx plus b. The coefficient of x is your slope. And that constant is your y-intercept. And so on your paper it says indicate the slope. So the slope is, in this case, negative 3/4. And the y-intercept is your constant, which in this case is a negative 4, not 4, but a negative 4. All right. Okay, number 12, they want you to determine, now you're given two linear equations here, and they want to know if the graphs of these lines here will be parallel, perpendicular, or neither. Well, to determine that, since you're given the equations, you're just going to find the slope. Now, you can't read this. Let me go ahead and rewrite this over. You have y equals 3/2 x minus 4. And then over here, so this is going to be my first line right here. I'm going to just call it line 1. And then line 2 is 4x plus 6y equal 8. So line 1 and then line 2. Okay? All right. So line 1, I can tell the slope right away, right? In line 1. Because it's in slope-intercept form, so the coefficient of x is your slope. So the slope here is 3/2. Now, I can't tell the slope very easily here, so I'm going to put this in slope-intercept form. So I'm going to get y by itself. When I do that, I'm going to go ahead and subtract 4x from both sides, and I'm going to get 6y equals negative 4x plus 8, right? And then dividing both sides by 6, and then reducing, I get y equals negative 4/6x plus 8 divided by 6. But let's go ahead and reduce. So this becomes negative 4/6 reduced is a negative 2/3 x, and then 8/6 reduced is 4/3. All right, so the slope of this line here, with this equation is equivalent to this. So the slope of this line is negative 2/3. Now compare the two slopes. Notice that the two slopes are opposite reciprocals of each other. So the two lines are going to be perpendicular. All right, so so it says explain. All right, so since the two slopes are opposite reciprocals of each other, so you have to indicate that the slopes. So you have to say this is 3/2, and you have to say this is negative 2/3 before you can say this. So since the two slopes are opposite reciprocals of each other, the two lines are perpendicular. All right, so if you graph them, they will intersect at right angles. All right, so that's number 12. Okay, number 13. So number 13, you want to find the equation of the line that contains this point and has this slope, and you want to write the equation in slope-intercept form. So I'm going to do this on another sheet of paper. So most of you probably used the point-slope form to do that. So this is number 13. And so your point is negative 6/8, and the slope is 3/2, right? So you probably use, so I'm going to call this approach 1. So approach 1, you probably use point-slope form. So remember point-slope form. And so point-slope form is y minus y1 equals the slope times x minus x1. And so in order to use point slope form, you have to know the slope and you have to know a point, and I do. So I know the slope is 3/2, and I know a point on that line is negative 6/8. So what we're going to do here is this negative 6, we're going to denote that as x sub 1, and then 8 will be y sub 1. So what we're going to do now is we're going to take all of this information, we'll put it back into this formula. So I have y minus y1, which is 8, equals the slope, which is 3/2, times x minus x1, which is a negative 6. Now, many students mess up at this point because sometimes they don't visually see that x subtract a negative 6 is x plus 6. So you need to write as x plus 6. So this becomes y minus 8 equals 3/2 times x plus 6. And now let's go ahead and distribute. I get y minus 8 equals 3/2 x. And then 3/2 times 6. So see, 3/2 times 6. So 3/2 times 6, 2 is 1, 2 to 6 is 3, and 3 times 3 is 9. So I get 3/2 x plus 9. And then finally, remember, you wanted the answer in slope-intercept form. So let's go ahead and get y by itself. So I'm going to add 8 to both sides. And when I do that, I get y equals 3/2 x plus 17. And so that's slope-intercept form. The other approach that some of you probably used is this one, approach 2. So approach 2 is to actually use slope-intercept form. So slope-intercept form. And so when you use slope-intercept form, remember slope-intercept form is y equals mx plus b. So to use slope-intercept form, you have to know the slope of the line, which I do. The slope of the line is 3/2. But you also have to know the y-intercept, which I don't. I don't know the y-intercept. All I know is that a point of that line is negative 6/8. That's all I know. So I got to find b. Well, in order to find b, you got to know an x and a y that's on that line, which you do. So here's an x coordinate on that line, and here's a y value on that line. And so we're going to take this information, we're going to substitute into here. So y is 8. So I get 8 equals the slope, which is 3/2, times x, which is a negative 6, plus b. And then multiplying these two numbers here, I get 8 equals 3/2 times a negative 6. 2 into 2 is 1. 2 to negative 6 is negative 3. So that's negative 9, right? Plus b. And to get b by itself, you're going to add 9 to both sides. 9 plus 8 is 17 equal, that's 0, and b. And so there's b. So therefore your answer is y equals, remember, slope-intercept form, y equals the slope, which is 3/2, and 3/2 x, and then you now know the y-intercept. The y-intercept is 17. And so notice no matter which approach you use, you get the same equation. Okay? All right, so that was 13. So 13, we have y equals 3/2 x plus 17. And then finally 14, so the same idea, except this time you want to write it in slope-intercept form and standard form. So slope-intercept form and standard form. Okay, so let's look at 14. All right, 14. All right. So we're given this point here. So we know that this line goes to this point, 5, -1. Now remember, you're also told that the line that goes to this point is parallel to this line right here, whose equation is -4x plus 3. So you're looking for the line that goes to this point. All you know is that that line here is parallel to this line. So if I'm going to find the equation of this line that contains this point, I must know the slope of that line. And it's pretty easy to find the slope of that line because this line is parallel to this line. And this line is already in slope-intercept form, right? Slope-intercept form. So the slope here is going to be -4. So the slope of this line is -4. Remember, parallel lines have same slope. So if this slope is -4, then this slope has to be -4. And now Now this right here looks like that one. So let's go ahead and do the two approaches. So approach one, we're going to use point slope form. Okay, so y minus y1 equals the slope times x minus x1. All right, so I'm going to go ahead and write the point here. So again, in order to use this point slope form, I've got to know the slope, which I do, and I have to know a point in that line, which I do. So 5, -1 is a point on that line. So this is x1, this is y1. So we're going to take that information, substitute into here. So I get y minus y1, which is a -1, equals the slope, which is -4, times x minus x1, which is 5. You got to remember that y subtract -1 means y plus 1, and then distribute the -4. I get -4x, and then -4 times -5 is a positive 20. And remember, one of the ways you have to write it was slope-intercept form. So let's go ahead and get y by itself, subtract 1 from both sides. So I get y, this is 0, so I get y equals -4x. 20 and a -1 is 19. So there's the answer in slope-intercept form. And then standard form, so you got to remember standard form means this. And let me go ahead and write this here. Standard form means to write it in this way. So where you have all the variables on one side, so we have ax plus by equal c. You have your constant on the other side. A, B, and C, A, that's A here. A, B, C are integers. No fractions, no decimals. Integers. And one thing you got to know is that A and B cannot both be 0. Can't both be 0. One of them can be 0, but not both. All right, so remember standard form, you got to bring all the variables to one side. And notice though, see this one's easy because there are no fractions to begin with. The coefficient here is 1, the coefficient here is -4, the constant's 19. Those are integers, so no fractions. So this is the easy kind. And so let me go ahead and rewrite this over. So I get -4x plus 19. And so we're just going to add 4x to both sides, and we're done. So, and let's put the x term first. So we get 4x plus y equal 19. So that is standard form. Okay? So notice the coefficient of x is 4. That's an integer. Coefficient of y is a positive 1. That's an integer. And the constant is 19. That's an integer. Now, I want to mention this, and we talked about this before. So remember where I had this right here, y equals -4x plus 19? Someone else, you see how I added 4x to both sides? Someone could have subtracted y from both sides, just to let you know that could happen. Y subtract y is 0, equal, and then this becomes -4x minus y plus 19. So this right here is 0. This right here, y minus y is 0, and then this right here is this. And then now subtracting 19 from both sides, I get -19 equals -4x minus y. This is 0. And then I can transpose the sides. So -19 equals -4x minus y. It means the same thing as -4x minus y equal -19. All right? And so this is also standard form. So either one, so in standard form, either this or this would have been fine. And to let you know, we know that these two are equivalent, so we didn't have to do all this to see that this is equivalent to this, because remember, what you do to one side, you do to the other. So if I multiply the left side by -1, I have to multiply the right side by -1. That's mathematically acceptable. So 4x times -1, -4x. Y times -1, -y. 19 times -1, -19. All right? And so if you did it, and if you did this problem using approach number 2, you would get the same answer. Okay? All right, so that is going to be the key to this test. So that's the key to test number 1.